Alright, hey, welcome back to Mr. P Helps with Algebra. This is Unit 3, Topic 1, Lesson number 11. We're going to talk about residual plots here for a moment, analyzing residual plots. So what are we looking for? We're trying to determine, is this line of best fit a good fit for the data? Is it a good fit or not? So when I look at this, I'm looking for patterns. Well, in this case, I notice that if you take these numbers away, there's a lot of numbers that kind of curve. That's not a good thing. So that tells me that a curve of best fit would probably be a better fit for this data because this is too big of a residual. Big residual, big residual, big residual. Well, okay, the curve wouldn't fix this one, actually. The curve would actually get it slightly worse on this one. But I think the curve would fit perfectly for these data points, and then you would just have 3 data points that have big residuals instead of 1, 2, 3, 4, kind of 5 right here, actually. And only 2 of them hitting the line instead of 5 of them hitting the line, or 6 of them hitting the line. Okay, so I would say a curve of best fit would better fit for this data. Another thing I noticed is that it's got a lot of big residuals, the fact that it's got more data on the bottom than it does on top. And keep in mind that a residual plot, a good residual plot, should have an equal amount of data on top and bottom because you want it to average out to be 0. You don't want to have huge residuals on one side and not on the other. This one, number 2, is a great plot. The pattern I notice is that it's going up and down. It's going, every single point is close to the line of regression. So that's another thing that I could say right here. And that's what makes this one a good line of fit. Every single point has a small residual. That's what you want when you're talking about a trend. If all the data matches the trend, then that's good. This one, it's very bad in the beginning. Big residual, big residual, big residual. So that's not good. But then it's a good fit at the end of the data. That doesn't mean it's a good model altogether. Once again, I'm thinking a curve of best fit probably would have fit this data better. It does have an equal amount of data on both sides, which is a good thing. But it's got too big of residuals in the very beginning. That's something I would mention here as well. All right, great. So talking about the homework. Now the homework is simply connect each of the points to the line and count about how far away is that point from that line of fit. Now I believe these are the exact same 2 sets of data. One has a curve and one has a line. And we're supposed to try to figure out, well, which one best matches the data. So when x is 1, this looks to be about 1 below. So I would say the residual is about -1. This one looks to be right on it. This point right here looks to be about 1 above. I'm just kind of eyeballing it here. That one maybe 2 above. This point looks to be quite a bit. That's more like 3 above. And then the next one is also about 3. The next one's about 1. Now keep in mind, I'm just eyeballing it. It's kind of hard to see with this small step. So that's 1 below. That's 0. And then the next one I would say is about -4. And then the next one, we don't really know. I'm going to say it's about -5 here at the end. So I know I'm not making it so you can just copy me, but if you're watching the video and you're listening to me, basically I'm telling you all the answers that you can write down. So as this one, I would say this is about 3 above, then maybe, is that 1 above, then 1 below, 2 below, 1 below, 0 maybe, 0, 0, I don't know, is that 0 again? And that one's maybe about 1 above. So just putting those numbers in order right here. Now you notice that all these numbers, I think there's only like 1 that I said, or 2 of them that were 2 above or below. All the others had a residual of 0 or 1. That's a great thing. So when you do your residual plot, the first one was 2 above. So 1 was 2 above. You put a point right there. And then the second one was 1 above. So you go to 2 and put a point right there. So this one was about right there. Now the pen's not working too great here. Third one was 1 below. So if you go to the third one, 1 below, like that. And you just do that throughout all the residuals. So all the way across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You put out all the residuals in a residual plot. Kind of hard to see these numbers. What is that? Is that 2, 4, 6, 8, 10? I think. Okay, if that's the case, then 1, 2, you should have a data point here, 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 in between each line and on the line. All right, let's talk about this lesson a little bit. So, first of all, I don't like years. I don't like years for x's. So I would change this to decades since 1800. So that means this is going to turn into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down to 21. So decades since 1800 makes these numbers, these x values from 1 to 21. Then put these numbers in your calculator just like you've been doing in the past. So you go to Stat, Edit, and then once you got all the data in, and then you're going to go to Stat, Calculate number 4. I know I've done this in other videos, and that's going to give you the equation for the line of regression. And the equation I'm getting, I'm rounding this a little bit, so I'm getting a slope of 0.2611. Now I'm going to just say 0.261 is good enough. X minus about 0.85. Yep, okay, so that's the equation I'm getting for a line of regression. And now I'm going to go back to Stat, Calculate number 10, which I believe is the last one on most of them. Oh, there it is, Exponential Regression. Enter, enter, and the equation I'm getting a, let's try that again. Stat, calculate, number 10, exponential regression, enter. There we go. It's thinking. Calculator takes a little bit more time on exponential, and there it goes. 0.286. I'm rounding that because 0.2858 would round up to 0.286 times 1.154. Now, it's important that you keep at least 3 significant digits, and the reason why is because rounding this to the hundreds actually would change the data quite a bit. So you do want to actually keep at least 3 significant digits. Now, by significant digits, I'm not including zeros. I'm talking about any other digit that's after the decimal. So I kept 3 digits here and at least 3 digits here. Great. Awesome. So now what I can do is go to y equals, put these 2 equations in the calculator. So one for y sub 1 and one for y sub 2. Once you do that, then you should be able to go to table, and then you're going to see on your calculator a list of all of the predicted values. Then you're going to do some subtraction. Now remember, this is 1, this is 2, this is 3, and so forth. The actual value, if I go back a moment, was 0.4. For the exponential function, when you put that equation right here into the function, into the y equals, and then you look at the table, you're going to notice that it says about 0.4, so, or 0.3, I think, something like that. So that's going to give you a residual of 0.1. Now, this model, you're going to tell, is very, very, very close. As a matter of fact, when you look at it, you can see this is just above by 0.1, then 0, 0, 0, 0, 0, 0, 0. A bunch of these are zeros until you get to like a -1 around here. So once again, look at the table, compare what it predicts on the table, and take the actual number minus the predicted number. So 0.4, I think the next one rounds to about 0.4. Now, notice that in the calculator, it's giving you big, long decimals. I round it to whatever the data is in. Since the data is in tenths, then I'm going to round my predicted values to tenths. So that makes it easy to subtract. So 0.4 minus 0.4 equals a residual of 0. Now, I know it's not exactly the same, but it's close enough to exactly the same. And then do the same thing for linear, but you're going to notice you're going to have a lot of big positive until it gets back to 0, and then you're going to have big negative residuals, and it gets back to 0 again, and then it goes back positive again. So, I mean, just look at these 2 lines. You can tell the curve fits the data so much better than the line. These are huge residuals. That is not good. That is not a good fit for this data. This data clearly curves. So what you should notice, the population, and that's the way population is pretty much all across the world, the population, it might go up and down more some years than others for some reason, whatever that might be, but for the most part, population increases at an exponential rate. All right, that's just the way population has always worked based upon history of the last, I don't know, thousands of years, pretty much. Okay, so then once you're done, you've got those, you can plot your residual plots, which we have done in other videos. I guess I'm going to have to go ahead and stop right there. I know I didn't show you a whole lot writing it down because it is a very tedious lesson in this case because you're doing a lot of subtracting. You're taking whatever was on the predicted on the front of this paper minus whatever predicted in your calculator, and that gives you your residual here. All right, thanks again for watching. Please give it a like to help you learn something about finding residuals or residual plots or using them to analyze, determine if it's a good line of fit versus curve of fit. All right, have a great day.